Here we go with the solutions to the transformations questions. So first of all, we've got some shapes on a grid. That's our first clue that it's a transformations question. And now it says reflect shape A in the y-axis. So there is absolutely no excuse for getting this wrong because you've been doing it since primary school. So notice it says y here. Double check you're getting the right line. This is the y-axis here, all the way down to the bottom, and to reflect it we just need to count some squares. So you can see this corner here is 1 square across, so we go 1 square this way, and then from the line of symmetry to this corner is 1 square, so that's there. Now this corner here is 1, 2, 3. Notice 1, 2, 3 from the line of symmetry, so we go 1, 2, 3 over to here. This corner here is also 1, 2, 3. So 1, 2, 3, and most people at this stage can start to see how it's going to look, and you should be thinking about those butterfly pictures. There we go, and that's the image of A. When you transform something, what you end up with is the image. Now, 2 marks for that. Now, part B. Describe fully the single transformation which takes shape A to B. So, going from A to B. Now, when you're doing one of these, you might find it helpful to think of terror, because this covers the various options you've got. So, you've got translate. That's sliding. You've got enlarge. You've got rotate. And reflect, or you end up resitting, although that is becoming less of an option for many of you. Anyway, here we go. So describe the single transformation. So first of all, we can rule out enlargement. It's definitely not enlargement because they're the same size. Translate. Well, translating is where you pick something up like this and you slide it around. And when you slide a shape around, you can see that it doesn't rotate, it doesn't twist, so you end up with the same shape. So you can see that if I was to trace shape A and then move it, it's not a translation. So we can rule out translation, because translations don't spin round. Now, looking back at this one, notice that it's the same way up as my original shape. Now I'm just going to try spinning my tracing paper around, and you can see that if I turn my tracing paper around like this, then actually it fits on top of it. So what that's telling me, the spinning around, that was rotating. So it's a rotating. So I can rule out all the rest. So I get a mark for saying rotation. That's 1 mark. Normally there's 3 marks on these questions. The next thing to say is to say the angle and direction. So that's a bit trickier. Well, I can do that with my tracing paper as well. If I go back to my original shape, remember it's A to B, then it's going to be a rotation, and I've got to go round. Let's bring it down a bit. No, the wrong one. Try again. Here we go. My aim is obviously off tonight. There we go, right. So it's a 90 degree, that's a quarter turn, isn't it? So it's a quarter, a half turn, 3/4, and then a whole turn. So this is a quarter turn, so 90 degrees, and it's that way, and that is anti-clockwise. So 90 degrees, anti-clockwise. And if you're playing safe, you also need to say where the centre of rotation is. And the way you find the centre of rotation, there's several things you can do. First of all, imagine this was spinning round. Where would it be spinning round? Well, I think it's going to probably be somewhere over here. And if I draw a line from there, you can see that it's the same shape there. So it is spinning around the centre, and this is a bit easier to do on tracing paper here, but what I do on tracing paper, as most of you will hopefully know, is you would trace shape A, you would put your pen on the tracing paper here, and you would spin it round and make sure it landed on top of shape B, which it will. So that's the last bit of information is the centre, and the centre is 0, 0. When I say centre, I don't mean the centre of the graph, I mean where the shape's rotating around. Question 2. It's a reflection question. A reflect triangle Q in the line y equals x. Well, this is the line y equals x, so you can tell us. Sometimes you have to draw it. And what I'd say to you is, when you're doing a question like this, something which will help you a huge amount is if you turn your paper round so that the mirror line is going vertically up your page. Because then you can see, well, that's going to go to there because it's half a square, isn't it? Now here that's 1, 2. So 1, 2, it's going to go here. Finally, 1, 2, 3, 1, 2, 3. So you can see that's my triangle there, and then this line's going to be a bit tricky to draw. There we are, and it says label it C. Hopefully you can see that, how that's sort of, imagine it was folded down the middle, the two triangles would land on top of each other, and that's reflection. Okay, you can do it with tracing paper, that's just one way of doing it, and there's 2 marks for that. Question 3. Rotate the shaded shape 90 degrees clockwise about the point O. So let's find the point O first. So here's O. Where's O referring to? It's referring to the centre of the graph. So there's my y-axis and my x-axis. So that's the point O there. It's not the letter, it's actually one of the crosses on the graph. And at this point, you would get your tracing paper and you would trace the shape very carefully. And you would put your pen on the tracing paper there, having left this lined up, and you would go 90 degrees clockwise. So clockwise is this way, and it means it's going to land down here somewhere, and it's going to land, if you do it, you'll find it lands like this. 1, 2, 3, 4, 5, and then whatever you do though, do try it with tracing paper, because they give you tracing paper in your exam. Why take the risk? So many people think they can do these by eye. I've just done that one by eye, and even I'm sitting here thinking, have I done it right? Don't take the risk in your exam. Part B. Describe fully. So remember, terror. Translate. Enlarge. Rotate. Reflect. Or reset. So, it's the same size, so we can rule out enlargement. It's the same way round, which means it hasn't flipped over, it hasn't been reflected. Reflecting is flipping. Rotating, well, it's the same way round, it's not a rotate, it's just been slid across the graph. Now, it's shape P to shape Q. So we start with shape P, and you trace shape P, and then you count to see how it moves. So 1, 2, 3 right. Okay, so 3 right and 1 down by the looks of it. 1 down. And again, don't take the chance of counting it without actually doing it with tracing paper. It's so easy just to trace the shape and slide your paper over and count. If you're feeling fancy, then you might write it as a vector. So 3 right is going to be there, that's your x number, and 1 down, well, that's -1 in the up and down direction. So up is positive, down is negative, right is positive, left is negative. And that's no surprise to you, because you can see the numbers, they're going up, it's adding, and if you go this way, it's subtracting, and the same going up is adding, and going down is subtracting. So that's how you know which sign it is. And that is your x, and that's your y. And just remember, this isn't a coordinate, this is not saying 3 along, 1 down, this is a movement, it's a vector. Finally, question 4, the challenge question. On the grid, draw an enlargement, so we're enlarging the shape, scale factor 2. So all the lengths are going to get twice as long. So this is 3, so it's going to have to get to be 6 big. So let's see if we can fit that in. It doesn't say where to draw it, so it doesn't really matter. So I'm just going to draw it up here. So let's go for red, shall we? So 1, 2, 3, 4, 5, 6. And this is 1. And scale factor 2 means we're doubling it, so it's going to be 2. That's 1, so that's going to be 2 as well. And then 2, and then 2, and then 2, and then 2, and then down here. 1, 2, 3, 1, 2, 3, 4, 5, 6. And that is twice the size. It's the length that have got twice the size. Every single length has doubled. And that is transformations.